We're going to go ahead and take a look at the zeros of polynomials. Whether we're talking about zeros or roots or x-intercepts, we're really talking all about the same thing. We're talking about where your graph would cross the x-axis or where the y value is 0. Now, the number of zeros that you have is always equal to your degree of the function. The degree is the highest exponent. Now, when you're looking at those zeros, they may be real or they may be complex or they may be a combination of real and complex, but it will always add up to the same value as the degree for the number of zeros. So as we take a look here, we are given our zeros, and we looked at a problem like this in the last section. So it's a Jeopardy problem, working backwards. You want to go ahead and set each one of your values equal to x. Remember, you want to go ahead and set each one of these equal to 0, so you'd have to subtract your 2 from both sides. Here you'd have to add 1 from both sides. Here you'd have to subtract 3 from both sides. Now when you're dealing with your zeros, what we have here for your zeros, these are the values that you have to then end up multiplying together to be able to get your function. And that would be what we have down below here. Your x minus 2, your x plus 1, your x minus 3. Now you'll notice there's a value of a in front. Now if we wanted, we could put a 7 here instead. And while it wouldn't change your zeros, because you'd still have 4 things multiplied together to give you 0, what would cause this one to be 0? Still 3. This one here, still negative 1. This one here, still 2. And your number in front would never be 0. So by putting a number in front doesn't affect your zeros. But what we do need to do is we need to go ahead and find that value of a so that it really goes through this point here, because that's really a point. Your x-coordinate is what's in the parentheses. What you get out is what we have right here. So this is your point. So all we're going to do now is go ahead and plug that point in for your x. So you're going to replace all your x's with 1. Replace your f of x with your 5. So when we do that, we end up with this. So then you get a negative 2 here. You get a positive 2 here. You get a negative 1 here. So you get a 5 is equal to 4a. So when you go ahead and solve it for a, you get 4/5. So for your final answer, you want to go ahead, rewrite your black equation here, but you're going to replace your a with your 4 or 5/4. Now, when you're looking at the number of zeros, that's what we have is 3 of them. Remember, the value in front of a does not affect your zeros. The value in front here affects which other points it will go through, not on your x-axis. So to find that, once again, you got to go ahead and plug your point in. Here we're talking about multiplicities. That's basically how often does that 0 show up in our problem. If it shows up once, it's more or less going to be crossing your x-axis as a straight line. Your whole function may not be straight, but how it's crossing your x-axis is going to be like a straight line. If it's even for your multiplicity, then it's really just going to be touching your axes there and bouncing off. Whether it touches and bounces off from above or touches and bounces off from below, doesn't really make a difference. But that's what's going on when you have an even multiplicity. It never really crosses to the other side. It only crosses to the other side if it's an odd multiplicity, and we talked about the odd multiplicity of 1 here. An odd multiplicity of any other odd number other than 1 is really going to come along, flatten out as it crosses, and then continue on down. Or coming up from the bottom, flatten out as it crosses and continue up. So an odd multiplicity greater than 1 flattens out. An odd multiplicity of 1 is more or less a straight line as it crosses. An even multiplicity bounces off. So take a look over here at this graph. We want to find our roots, and we want to look at the multiplicities, and then from there we want to be able to write our answers. So as you look over here, your roots are where it's crossing. So here at 1, at 0, and at -2. So those are your roots. Well, let's go ahead and take a look at your multiplicities here. When you're looking at 1, at how it's crossing here, isn't it more or less a straight line right here at 1 where it's crossing? We're not real concerned about going real far above or below, but just near where it's crossing, it's more or less a straight line. So we know at 1, it's a multiplicity of 1. It's going to show up once. Here at 0, though, it doesn't actually cross. It just bounces off. So that means it has to be an even multiplicity. We don't know which even from just looking at the graph, but I'm going to just choose the first even and say it's a multiplicity of 2. Over here at -2, it's really an odd multiplicity other than 1 because it flattens out as it crosses. Your first odd number above 1 is 3, so I'm going to say it's a multiplicity of 3. Just from you looking at your graph, we don't know for sure if it's a 3 or a 5 or a 7. Now, when you have your multiplicities and you have your zeros, you should be able to write your function. So, we have an x being squared here because your 0 is at 0. So when you're working this out, you know what's going to create this to be 0 is 0. We had that here. We know at 0 it shows up twice, so we need to have an x squared. Then we have an x plus 2, because your x minus 2, when you set x equal to 0, or set x minus, if I can talk here, x equals -2, set that equal to 0, you get that x plus 2, and that's where this comes from. Now we also have the other one of an x minus 1, because x minus 1, what causes that to be 0? That's your 1. And that only shows up once, so your exponent's 1. Basically, your multiplicity tells you your exponent you're going to have on that factor. So, looking at this one here, you want to find your zeros, your y-intercept, and sketch your graph. Well, your zeros are the things that would cause your parentheses to be 0. So your zeros are your 3 from the first parenthesis, your -4 from the second parenthesis. But since you have an exponent of 3, it shows up 3 times. So it's a multiplicity of 3. Then from your last parenthesis, you get a -1. Exponent is 2, so it's a multiplicity of 2. Now, if we would go ahead and actually work this out, you'd see that your x plus 1 shows up twice, so you get a -1 from this last one, a -1 from this one here, shows up twice. From here, these 3 in the middle, you get a -4 showing up 3 times, so that's why it's multiplicity of 3. Your y-intercept is what you get when you just plug in 0. So then when you plug in 0 here, you're going to get your 1 over 64 times a -3 times your 4 cubed, which is 64, times your 1 squared, so 1 squared doesn't change it, your 4 cubed is 64. That undoes your 1 over 64, so you get -3. So we know we cross at -3. We have our zeros at 3, at -4, and at -1. At -1, we know we got to bounce off, but we know we got to go down through this point. At 3, you know you got to cross pretty much as a straight line coming down from here. And then over here, we know we got to come back up, and we got to flatten out as we cross because it's an odd multiplicity. So that's essentially what we have here. Now, necessarily how far down we go on each one of these, we don't necessarily know that until we actually plot points, which we did not do. We're just looking for a sketch.